Hello everyone, my name is Hussam, and today our topic is filtration. I'm gonna walk you through one of the most important tools in bioprocessing, which is filtration, especially microfiltration and stereo filtration. The big idea is simply filtration separates by size using a porous barrier. So in this short presentation, we will explain first why filtration, what is filtration, and why we use it in biological engineering, and the key concept of pore size, and the two main filtration setups, which is dead end and cross flow. And now with Riyadh.
Hey, on this slide, we're talking about filtration in bioprocesses. To understand filtration, think about something we all do, which is making coffee. When we make a coffee, the filter keeps the coffee grounds on the side and lets the liquid pass through. Bioprocesses work in the same way. Filtration is one of the quickest and most important steps in biotechnology. We use it to remove a cell from microbes from a solution or to sterilize the liquid before it enters a bioreactor.
Hi, I'm Bader. What filtration is? Filtration is basically a separation method where a liquid passes through a material and the larger particle get trapped. The liquid that makes through the filter is called filtrate. The material that stays called the retinate, and sometimes it's built up into what we call a filter cake on the surface.
Hi, I am Abdul. So why we use it in biological engineering? We have three steps: bioreactor, then filter, and then clear bottle. In biological engineering, filtration shows up everywhere. Using a filtration, one of them harvesting, which is separating bacteria or yeast from fermentation broth. Also, purifying, where we removing cell debris or particles after cell lysis. As well, sterilizing, we are removing microorganisms from a solution like vitamins, buffers, or media components.
Important idea in all filtration, which is pore size. Think of pore size as the main design knob we can adjust. It's basically the size of the holes in the filter. So if the pores are small, separation becomes much better. But the flow slows down and the filter tends to clog faster. To give a quick example, if you want to sterilize a solution, we go even smaller, typically 0.22 micrometers, which is small enough to stop bacteria from passing through. And now, Riyadh.
On this slide, we have to most common ways to run a filtration systems, which is dead end and cross flow. Dead end filtration works just like a regular coffee filter. The liquid hits the filter straight, and everything that doesn't pass through stays on the surface. It's simple and cheap, and it's for small volumes. The cross flow filtration works differently. Instead of hitting the filter head on, the liquid flows across the surface of the membranes while only part of it passes through. That makes the cross flow much better for large volumes and for cell culture streams.
In real life, filters don't stay perfect. As a particle starts to build up on the filter, it becomes harder for a liquid to pass through. That means flow rate gets slower, or you have to use more pressure to keep the same flow. This problem is called fouling or clogging, and it's one of the biggest particle limits of filtration and bioprocessing.
To wrap up, filtration is separating by size using a porous barrier. Pore size control what gets through and how fast. So we learn two ways of filtration, which is dead end and cross flow.
Thank you for
That's
listening.
Thank you.